Thank you for joining this lesson. We're going to discuss quantity of heat, the change of state. This is the phone number you should be contacting to request for revision materials and also to do some consultations. Question 1. In an experiment to determine specific latent heat of vaporization of water, steam of mass 12 grams at 100 degrees Celsius was passed into 80 grams of water, initially at 23 degrees Celsius, in a container of negligible heat capacity. The temperature of water rises by 74 Kelvin. Use the information to determine specific latent heat of vaporization of water. Then we're taking specific heat capacity of water as 4.2 kilojoules per kilogram per Kelvin, and the boiling point of water as 100 degrees Celsius. So what we should know is that in this case, we got steam of mass 12 grams, which is at 100 degrees Celsius. That means steam is already at its boiling point. That is to mean it is exactly at the temperature where it should, in case of a decrease in temperature, should start condensing back into water. Therefore, in this case, there is steam which is at 100. This steam is going to lose its energy until it first of all condenses into water. Then it will decrease in temperature until it meets the temperature of water, which is also rising from 23 degrees Celsius to, a change of 74 Kelvin will mean a change of 74 degrees Celsius. Therefore, the steady temperature attained in this case, the steady temperature attained is going to be 23 plus 74. This is going to be 97 degrees Celsius. So that is the common temperature attained. If that is the common temperature attained, steam is condensing, then losing heat from 100 to 97, whereas on the other side, water is rising in temperature. It's gaining temperature from 23 all the way to 97. Therefore, it should also be noted that water is in a container that will not absorb heat energy, or rather, the heat energy absorbed by the container where water is negligible. Therefore, we're going to say heat lost by steam will be equivalent to the heat gained by water on this other side. There is no stories of plus heat gained by container because the container will absorb negligible heat. So now on the steam side, there is the mass of steam 12 grams, so we divide by 1,000 to make it kilograms, times latent heat of vaporization, which is unknown. This is the heat lost so that this mass of steam might condense into water. Then after it has condensed into water, now the same mass will decrease now that it is water. Specific heat capacity of water times change in temperature from 100 to 97 is going to be 3. The change of temperature will be 3. Now that heat will be equivalent to the heat gained by water on the other side. We have 80 grams of water, so 80 divided by 1,000 to make it kilograms times 4200 multiplied by a change in temperature of 74. A change in temperature of 74. So we can have 0.012 latent heat of vaporization of water, or rather of steam, plus 12 multiplied by 4200 multiplied by 3. Then we divide this by 1,000. We're going to get 151.2. This is equal to 80 multiplied by 4200 multiplied by 74 divided by 1,000 This is going to give us 24,864 joules of heat energy. Joules of heat energy. Therefore, now we can subtract 151.2 that side. So that now when we divide by 0.012, we're going to get latent heat of vaporization of steam as 2,059,400. This should be joules per kilogram. Joules per kilogram. Because there is no change in temperature that is happening at a constant temperature. Specific latent heat of vaporization of steam is given as that value. The next, we have another question here now, which is telling us that a well-lagged copper calorimeter together with a copper stirrer of total heat capacity 60 joules per Kelvin contains 200 of water at 20 degrees Celsius. Dry steam at 100 degrees Celsius is passed in, while the water is stirred until the content reach a temperature of 50 degrees Celsius. Determine the mass of the condensed steam. So steam is going to condense as it is passed in a calorimeter containing water. They are at 20, but now a common temperature of 50 is attained. So in this case now, the question is not the specific latent heat of vaporization of water because that is given. What we want to know is the mass of condensed steam. Therefore, heat lost by steam, is going to be equivalent to heat gained by water on the other side, and also heat gained by calorimeter. Heat gained by calorimeter. Therefore, in this case now, water is in a container that absorbs heat energy with a certain heat capacity. Therefore, heat lost by steam. Remember, steam is first of all going to condense. Therefore, we will have the mass times latent heat of vaporization of steam. That is the heat given out so that the steam might condense first. So you'll have 2,260,123 because it is times 10 to the power of 6. That is the heat required by steam or given out by steam to first of all condense. Then now after it has condensed, it drops in temperature now from 100. Remember, immediately after condensing, it becomes water at 100. So it has to decrease in temperature from 100 to 50. That means the unknown mass again times, now that it is water, 4200, times the change in temperature, which will be 50, from 100 to 50. This will be the same as the heat gained on the other side by water. So water is 200 grams. We make them kilograms times 4200 multiplied by change in temperature. They were initially at 20 and now at 50, so the change is going to be 30 degrees plus the heat gained by calorimeter. Also, heat gained by calorimeter together with its stirrer, they are made of copper, and the heat capacity is 60. We should know that quantity of heat is heat capacity is capital C times change in temperature. Therefore, we're going to have the heat capacity of 60 times a change in temperature also of 30. Therefore, we can now add 2,260,123. Then we add 4,200 multiplied by 50. This is going to give us 2,470,123 mass equals to the other side. Now we'll have a 200 multiplied by 4200 multiplied by 30, then we divide by 1000. 25 200, then we add 60 by 30. This will give us 1800. Therefore, to remain with M, the mass of the condensed steam now, what we need is 200. We add to this value, then we divide everything now by 2470 and 3 other zeros. This is going to give us 0.01093 kilograms. So that is the mass of the condensed steam. We can multiply by 1000, 1, 2, 3 to have 10.93 grams, which is not a necessary conversion anyway. In kilograms, the answer is correct. So that is what is happening. There is change of state whereby steam has to first of all lose heat to condense to water, then now drop in temperature from 100 to 50 degrees Celsius. Thank you for following. Subscribe to this channel and share the link with friends.